This is IAT 355 Visual Analytics, Lecture 4.1. In this lecture, we're going to talk about visualization tasks with Excel and/or Tableau demos. We'll focus on Excel more on the first half and then move towards more Tableau examples in the second half of Lecture 4.1. So let's just spend a little time talking about what tasks are about. And one of the things that can sometimes be a bit confusing, as was implied by the clip art you just saw, is if you're building a visualization tool or adding elements to a visualization or an analytical system, you as a designer or an implementer need to decide what kind of tools to put in the system to add to the visualization or to add to the tool. And of course, like any design task, those decisions that you need to make need to be put in a form that the user can understand and the user can grapple with. So part of the reason for this lecture is to establish common terminology and to some degree give a list of kinds of things that you would expect to see in a visualization tool. The end user, if you're acting in the role of a designer, of an analyst or a visual analytics user, you need to be able to discover what kind of tools are available in the tool and in the system, and to find out what kind of tasks that I can use to get what I need. And so one of the things that we're going to talk about today is a suite of kind of the basic tasks and organizational ideas that you will find in visualization tools. So to get at this kind of question, researchers over a number of years have investigated this question, sometimes because the techniques that have been developed have come from a computer scientist point of view, in which there is, computer scientists developing tools, developing better and better techniques to deliver tools, and putting those things into an organized whole, just takes some effort. And some tools will, be absent things that real analysts would really need, and that, sort of made the tool hard to use, or, stymied progress where you would expect to make some. So what we're going to talk about is a task taxonomy, as it is an organizational set of ideas as to what kind of tools visualization systems ought to provide. And each of the taxonomies that have been published focuses on a different aspect of InfoVis and visual analytics. One of the tasks is, one of the foci is creating an artifact. Another focus is about human tasks, the kinds of things that people think about when they're doing analysis. And a third is those kinds of human tasks, those analytical needs, formulated or reformulated through the use of visualization systems. So Robert Amar and John Stasko created a taxonomy of user tasks that were used in visualization environments a number of years ago. And they came up with 10 basic actions that visualization systems ought to support. And they are: retrieve value, filter, compute derived value, find extremum, sort, determine range, characterize distribution, find anomalies, cluster, and correlate. And as you can see from this list, the first things in the list are very simple and very straightforward, whereas the stuff near the end of the list is somewhat more complex. And to some degree, some of the latter tasks depend on the findings from earlier tasks in the list. So cluster and correlate, for example, depend to some degree on characterizing distributions. So let's get started on what the tasks are in some detail right now. So the first one that we have is called retrieve value. And the way in which retrieve value works is just simply, given a set of specific data cases, find attributes of those cases. And those are, very straightforward things. So for example, from the car data set, this is one of the standard kind of toy data sets out there. What is the mileage per gallon of the Audi TT? Or how long is the movie Gone with the Wind? And now what we're going to do is show an Excel example of doing that. So there's Excel now, and we'll just scroll up to the top of this. So this is, once again, the college degree by state and median income by state data. This is, as the little label up here indicates, 2018 data. And what I've done is gone to public data sources and get an estimate of the number of people in the state who have a college degree, and a separate estimate from a different source of what the median income is for each state, and that is from 2018, that's income data. So retrieving value is, for example, very simple. In this case, we just simply look in the table for the item that we're interested in, and the question says, what's the percentage of Californians with college degrees? And the answer is 32.6. And what's Colorado's median income? Next line, just go there and click on the list and look it up. And this is a visualization task that we're doing just by looking at the raw data item. And some of the other things that you can do with this, say in Tableau, is hover above an individual data item and wait for the tooltip to pop up. So the next task that we're interested in is filtering. And the general description is, given some concrete conditions on attribute values, find data cases satisfying those conditions. And whereas the retrieve value thing was about finding a data case's individual value for some variable, filter is about identifying a set of data cases that meet some criteria. And so, for example, here in the examples, one example is what Kellogg's cereals have high fiber, and so there's a double query going on there. We're selecting Kellogg's cereals, and then within that we're selecting those which have high fiber instead of low or medium. What comedies have won awards, so we're selecting comedies and awards together, and which funds have in a mutual fund database have underperformed the S&P 500 index. Each of those things have acts of selection and filtering to focus our attention on a subset of the data that we have. Last on this list, what states have more than 30% of citizens with college degrees? So let's switch over to Tableau. And what we can see here is we've got as the label down here says, we have the state education versus income located right here, right? And I preloaded that data, and what I'm going to do is put the college degree thing in the columns location, and put the median income in the rows thing. So just one more thing, I'm just going to switch over to a more focused view. And what you can see after we did that is that the college degree and the rows, it says sum, and so we just get the single reading up here. It's summing all those things up, which doesn't make sense. But one of the things that we can do to adjust that is in the analysis menu, pop up and unselect aggregate measures, and that gets us all of the individual data points. Okay, and those are just listed kind of as numbers, but they're scatter plotted in the appropriate spot. What I'm now going to do is drag in the state thing into a label, and then we can see the labels pop up, and we get to get a good sense of what the range of things are and what states have low and high income and so on and so forth. So to do filtering, one of the things that we can then do is just select a range, and what I'm going to do is select roughly 35% of people with a college degree and greater, and then just going to drag out an area way up to the right here. So now that I've selected those states with percentage college degrees of 35 or greater, I need to turn on, once again, the aggregate measures thing, And what that does for us is when I go over here and hover above an individual state, is I have the option of being able to include or exclude those that I've selected. And what I'm going to do is I'm just going to go do keep only. And what that does is it creates a subset of the total set of states, and those, of course, are the ones above 35% in terms of college degrees. In Tableau, what I can do next is I can go to the filters card, which is automatically filled when I did that keep only operation. And what I can do is go down here, and what I can do is create a set. And the advantage of doing this create a set is that I can then use this filtered group for Minnesota, New York, Maryland, etc. later on. And so what I'm going to do is do that create a set thing. It pops up a dialog, and what I can do is just change the name of it. I'm going to say greater than, and just say OK there. There's some other options in this dialog. I don't want to drill down on a Tableau tutorial too much, but just to give you an idea, I can then create that, and then what you say is it popped up this thing, and then I can use this thing later and put this back in the filter box. So if I get rid of this out of the filter card, you can see everything. And if I drag this back in here, once again, I get those ones that I had selected. The advantage of doing this inside Tableau is that when I make a move to identify a subset of items, to filter a bunch of items, I can, in some sense, take some steps to remember and store inside Tableau what that selection was, and that can be really valuable. Okay, now let's get back to the slides. And so what states have more than 30% is what I said here. I did 35% in Tableau, but it's the same concept. Next on this list is compute derived value. And the general description for that is, given a set of data cases, compute an aggregate numeric representation of those data cases. Now that depends strongly on what kind of data you're looking at. Sometimes summing things makes sense. Sometimes taking an average makes sense. Sometimes both of those things will make sense. In our data that we're about to look at, adding up things isn't so sensible in all situations. But in any case, the examples are, what's the gross income of all stores combined? That makes sense if you've got a commercial database, a commercial data set in which, adding up all the dollars earned by the stores makes some sense. How many manufacturers of cars are there? That's just simply counting up an integer number. And what I'm going to show now in Excel is what is the average income in the US. Now, there's a little proviso I'll get to in a bit with respect to that, but we'll get to it when we get to it. So let's go to the Excel example once again. And so here we have our table. And one of the things that we can do in Excel, of course, because it's a little bit more low level in terms of its concept of how to do things, I can just type in a formula very directly that satisfies my query. So what I'm going to do is just once again type in average, which is Excel's formulation for the mean, right? And so that's the formula that's being typed in as I go here and indicating the range. And I get this blue box indicating what the range is. Hit return, and once again the Excel jumped back down to the bottom to show the result of doing that. And the income is $61,549, which is ironically very close to Wyoming's income. Taking the average in this case makes some sense, but the little proviso I wanted to point out is we're averaging medians here. So this wouldn't yield the same number as taking everybody's income in the US and dividing by the number of citizens that you counted. You probably get a different number because this number here, averaging by a state, ignores the fact that some states have higher populations than others. Wyoming's population is much less than, say, Washington's or Virginia's. So, but in any case, at least it's not insane. Adding these numbers up probably wouldn't make too much sense. Just because adding incomes across states is not quite sensible given the kind of data that we're staring at. In Tableau, one of the things that we can do, so let me just slip over to Tableau for a second. In Tableau, once again, we're still at the situation where we have the subset identified. So I'm going to get rid of the states highlight thing, just take it out of the filters list, and so therefore we have filters list, and then we have everything back again. And I'm going to go to the Analytics tab up here, right beside Data, up in the upper left corner, and I have a number of options that do analytical things. And what I'm going to do here is select the average line, okay, and drag that into the scene. And I have three possibilities. For this particular data set and this particular view, table, pane, and cell will all end up doing the same thing because there's one pane and one cell and one pane in the table. So I'm just going to drop it here, and then I get the average for the median income dimension, and that's 61,549, just like we computed in Excel. And I have the average number for college degrees, and that's 30.11. So that's computing the mean here and the mean here. So very straightforward type of computation. And these things stick around for as long as you want them. And what happens is when you change the content of in this display, the average lines also change. So let me demonstrate that. Here once again are our states with greater than 35% college degrees, greater than or equal to really. I do that and it moves the two average lines. So what this thing is doing is showing you the average for the current data that's currently displayed or filtered. Okay, so let's get back to the slides and go on to the next thing. And the next thing is finding Extremum. And the general description is to find data cases possessing an extreme value of an attribute over its range within the data set. Sometimes we can just eyeball this, but if we have a complex data set, it might be the case that there's extreme values anywhere are located, kind of geometrically within the data set, as it were. So what you need to do, particularly if the data set gets more complex, is you need to do some analytical steps. So the example questions are: what is the car with the highest miles per gallon in the cars data set? What director or film has won the most awards? Maybe it's Titanic, maybe it's The Godfather, I don't know. The third question: what Robin Williams film has the most recent release date? That's a compound query in which the filtering query has been done first to select Robin Williams films, and then within that find the most recent date. And for our running example of state incomes versus college degrees, what I'm going to do now is go to Excel and just show what that looks like in Excel. So one of the things that we can do in Excel, of course, is issue another formula. So if we want the maximum, for example, just once again highlight the range that we want. And that tells us the max, and that's 83,242. And we could also execute the minimum formula. But that's simply Excel's answer to that query of what's the maximum. To answer the question in Tableau, to those kinds of questions in Tableau, once again, we'll get rid of this. And one of the things that we can do is we can once again go to the analytics pane. But before I do that, I'm just going to get rid of this and get rid of this, mainly because it'll be a visual distraction if I don't ditch that stuff. So I'll go to the analytics pane. And what I'm going to do is I'm going to do a Boxplot. We mentioned Boxplot in the stats lecture, and I'm going to do one here. And so just like before, I have the opportunity to drag it into the scene. But what I'm going to do is I'm going to put it instead of in the entire cell, which creates two box plots, which is visually confusing. I'll demonstrate that in a sec. What I'm going to do is I'm just going to put it into the income pill or dimension. So I'm going to drop that there. And what we see is a very large box plot that encompasses the entire display. The entire vertical extent is probably bigger than it should be, but in any case. And so when I hover above this, I get the various values that the box plot is depicting. I can see it directly that the maximum is up here at 83,000 or so, and the minimum is 44,000. But also, when I hover above this, it can tell me the upper whisker, that's that guy, the upper hinge, that's this one here, the median, that's here. So remember, through the middle of the box plot, there's a line that indicates the median. The lower hinge, and the lower whisker. So these whisker and hinge terms come from the stats literature, which is the original source of the idea of drawing box plots. I can also draw a box plot in the opposite direction, and here it is. And as I said, it's a little confusing to look at, in particular because at the lower end, you know, in this particular instance, both of the box plots have their lower whisker centered on the West Virginia data point, and it can be a little bit hard to read. And I can also put in the average line, put it in the table, and I get all sorts of linear information there that's just very hard to read. You know, you can go too far by annotating. And Tableau is kind of, in some sense, not really built for doing graphical layout. It's computing this stuff automatically. And, you know, just the drawback is that you will get a lot of overdraw. So just watch out for that. But, you know, within Tableau, you can just delete this stuff. So I'm going to do that. So I'm going to do that deletion off camera. And let's move on to the next item, which is sorting. And sorting is often an activity that you want to do on the way to doing something else. But in any case, the general description is: given a set of data cases, rank them according to some ordinal metric. It could also be interval or ratio data, but it could also be alphabetical, except you're using sorting alphabetically for the purposes of enabling search to go easily, run by a computer system, or you searching visually through the data that you might have. But in any case, examples are: order the cars by weight, rank the cereals by calories, putting them in order. And what we're going to show now in Excel is order the states by percentage of states, citizens in a state with a college degree. So in order to do that, I'm going to be popping up some menus. So let's once again put that at full screen. So one of the big mistakes you can make in Excel when you're sorting, so the question says sort by college degree, but if I were to select this column all the way to the bottom and then sort it, a big mistake you can make in Excel is to neglect to select all of the data together. Sorting on college degree will simply give me the college degree percentages in order, but if I were to do so, I would lose the relationship between 29% in Georgia and 58K. And that's not good. Excel enables you to do this, and it does actually warn you about trying to do that. But I just want to, create a kind of a general warning. Watch out for doing things like that, because it can really screw your data up. And although Excel does warn, it's, it won't prevent you from doing that if you override the warning. So now that we've selected everything, I've left the headers out. I can then go to the Data tab in Excel, and that presents me with the opportunity to sort here. And you get the hover box saying sort. And here's what the sort dialog looks like. I had the choice of selecting all that data with headers or without. I didn't select headers, so I'm going to leave this unchecked. Anyway, and I can sort, and you select according to column names in Excel's ABC lingo. If you turn on headers, it picks off the header name and fills the column the column name with that. And so what I'm going to do is sort by column B, which is the college degree thing. Hit OK, and now we see college degree percentages in order from lowest to highest. So that's the end of the first set of visualization tasks 1 through 5. We're going to continue this segment in lecture 4.2 to pick up where we left off for visualization tasks 6 through 10.